You're sitting in a meeting when the conversation accelerates into a flurry of technical shorthand: API, CI/CD, Kubernetes. Even for an experienced professional, the sheer density of these terms can make it feel like you've been physically pushed outside the circle of the conversation. The common instinct is to reach for a dictionary, but memorizing technical definitions rarely solves the problem. You end up with a collection of dry sentences that don't explain how any of it actually works. There is a more effective way to enter the room. Instead of studying the word, look at the repeated problem the word was created to solve. Every concept in a digital system exists because a builder needed a way to carry evidence, learn a structure, or act under a specific limit. Think about a hammer. It exists because someone needed to strike something with force and control. When you see the nail, the hammer makes sense. Technical terms work the same way. Once you see the operational friction, the word becomes a functional tool. This approach allows us to see the 5 pillars of technology: software, data science, AI, cloud, and cybersecurity as one connected map. They aren't separate subjects. They are the stages of building and running a single digital promise. By focusing on these first principles, we can move past the noise of the vocabulary and watch a system come to life from the ground up. Every digital service begins with a human need. To turn that need into a working system, builders organize the work into 2 distinct roles. The front end is the visible, interactive layer that translates your actions into system commands. The back end is the hidden engine that processes rules, coordinates services, and talks to the database. These 2 sides need a defined way to talk to each other. This is the API. It's an agreement, a protocol that ensures the visible side and the hidden side can exchange messages without confusion. As this software conversation takes place, it generates a trail of activity. This is the entrance to data science. We call this recorded experience data. When we gather these traces together, they form a data set, a collection of past events that we can study to understand how the system is actually being used. Because recorded experience is often messy, we use cleaning to repair records. Then we can apply metrics, specific numbers that help us judge if the system is keeping its promise. Software manages the interaction, and data science turns the memory of those interactions into evidence for our next decision. When the volume of that evidence becomes too massive for a person to analyze, the system needs to find its own patterns. This is where we move into artificial intelligence. Instead of writing a fixed recipe, we build a model, a mathematical structure designed to learn patterns from data and support predictions. Through training, the model studies examples, correcting mistakes to map inputs to outputs. But it needs a stable home. Requiring power and connectivity beyond a single machine, we look to cloud and DevOps. Software now leaves the laptop, becoming a global service. The cloud is computing capability, storage, processing, and networking, accessed through a provider's infrastructure. DevOps is the discipline that ensures the builders and the operators share responsibility for that infrastructure. Deployment is the movement of code into this running environment. Monitoring is how we listen to the system's signals to ensure it remains reliable under the pressure of real-world use. AI provides the system's intelligent behavior, while cloud and DevOps provide the physical ground and the operational care required to keep it running. Because the system now manages data and makes decisions at scale, it possesses real-world value. Protecting that value is the role of cybersecurity. Security begins by naming exactly what we are protecting: the assets. This could be customer privacy, financial records, or the system's ability to function. We then identify threats, the events that could cause harm, and vulnerabilities, which are the specific weaknesses in our code or processes that might allow that harm to happen. To manage this risk, we implement controls. These are the rules, habits, and tools designed to verify identity and block unauthorized access. Cybersecurity is the organized practice of keeping a promise. It ensures that the system we've built remains dependable, even when the environment becomes difficult. We can now see the digital system as a single, living chain. Every piece connects. Software generates data, data informs AI, AI runs on the cloud, and security protects the entire process. This perspective changes how you hear technical language. Back-end API timeout is no longer an intimidating phrase. It's a description of a specific delay. the hidden engine room is taking too long to answer our request. When you understand the operational need, you can follow the logic of the system. You're no longer guessing at definitions, you're observing a workflow. Professional clarity begins when you look past the vocabulary and ask what responsibility each term names. The more you practice this, the more visible the system becomes. This is the central habit of the first principles terminology ladder. Start with the problem, and you can build a more resilient understanding of the technology that shapes our world.